Hello everyone, from Math 2200, Discrete Mathematics. It's Professor Wenson here again with a video on your ZyBooks Section 3.3 titled Union and Intersection. So this is a section where we're learning about some set operations, and what you're going to notice is that the union and intersection operations on sets are going to be very similar to the disjunction and conjunction, right? The inclusive or and the and operations from the logic chapter. And you've probably seen these before as well in like an algebra class when talking about compound inequalities. You may have seen these words, this notation before. Okay, so sets can be combined in different ways to define new sets. Here are some this is just a couple operations to do that. Make new sets from old sets. So the set intersection operation. So let A and B be sets. The intersection of A and B, denoted as A intersect B, right, this upside down U is the intersect symbol. It is the set of all elements that are elements of both A and B. So this intersection symbol acts like the conjunction symbol from logic. An element will be in set A intersect B if it's in both A and B at the same time. Alright, so they give an animation here. I'll play this one. Alright, so set A contains elements A, B, C, E, and F. Right, there's a little circle there with set A in it, with all the elements of A. Set B has D, E, F, and G. Right, so there is some overlap, right? They both contain E and F. So this overlapping region, again, is called the intersection, right, where the two sets intersect, where they have the elements that they share, the elements that are in both of them. So then the two elements in both A and B are E and F. Right? So the set A intersect B is simply the set with elements E and F in it. Right? The green, colored in green, that represents A intersect B. And hopefully pretty simple. And they give another example here. I'll let you read that. Then you have the set union. The union of two sets, A and B, denoted A union B. It's just a regular old U symbol for, think about it as U for union. This is like the disjunction operation in logic. Remember that inclusive or. An element will be in set A union B if it's in either set A or set B or both. Right, so it's a set of all elements that are elements of A or B or both. It's the inclusive or. Right. So yeah, the definition for union uses the inclusive or. Right. Okay. And then they go through the same kind of thing here. I'll play it for you again. Right, so same sets A and B. Right. A is set with elements A, B, C, E, and F. Set B is the set with elements D, E, F, and G. And so, all these elements, A, B, C, E, and F, they belong to set A, so they also belong to A union B. And all these elements, D, E, F, and G, they belong to set B, so they also belong to A union B. Right? And, yeah, I counted E and F twice, but there's no need to write E and F twice, right? There's no need to repeat elements. So every element that's in either A or B or both belong to A union B, and notice it's all colored in. Right? All of set A, all of set B. So again, pretty simple. Like I said, you've probably seen union at least in algebra class or pre-calculus. Right? You've most likely seen the union symbol when writing interval notation. And then again, you can read this example on your own here. All right. So I'll go through a couple of these. All right. We're given some sets. Set A has the elements 1, 2, 4, 11, and 12. Set B has the elements 2, 4, 7, 8, and 11. Set C is in set builder notation. It's all the integers, remember that Z represents the integers, that are even. So set C has elements, 0, 2, -2, 4, -4, 6, -6, and so on. And set D is all the integers that are odd. So set D has the elements 1, -1, 3, -3, 5, -5, and so on forever. And it's an infinite set. So what would be an A union B? Remember, this is the union symbol. So any element of A or element of B or both is in A union B. So we'll have 1, 2, 4, 11, 12. Also 2, 4, 7, 8, and 11. Now I don't need to write 2, 4, and 11 twice. So I just have 1, 2, 4, 11, 12, and then 7 and 8. So all the elements that are in A or B or both, and that's this set here. How about B intersect D? That's the upside down U. This is like and. What are the elements in both B and D at the same time? So the elements of B are 2, 4, 7, 8, 11, and D is all the odd integers. So if I'm in B and D, we're basically looking for what odd integers do they share, right? What are the odd integers that are in both? So 2 is in B, but it wouldn't be in D, right? So not 2. 4 is in B, but it wouldn't be in D, right? 8, same thing. All the even ones are bad. 7 and 11, though. They're in B, and they would be in D also. So so B intersect D would be the set with just 7 and 11 in it. Okay. All right, and I'll leave the rest for you to figure out. So because I did one example of a union, one example of an intersection. You should be able to do the other three. All right, and here's another. Now this is, we get into multiple set operations. So my only advice to you is just remember, do the expressions in parentheses first. So in fact, I'll write this one out and do it on a piece of paper, and you can see the coloring in here, and I'll play the animation even afterwards. Okay, so here I have the 3 sets written in that activity. And we're asked to find the new set A intersect with the set B union C. So like I was saying, you're going to do stuff in parentheses first, right? So first, I'm going to figure out what is the set B union C. I'll write this down. So B union C. Now remember, this is the union. This is like that inclusive OR from logic. So the elements in B union C are the elements in B or C or both. So look at B and C. There's a 2, so that'll belong to the union. They have 3's, so 3 belongs to the union. There's a 4 in there, 4 belongs to the union. They both have 5's, so 5 belongs to the union. There's a 6 in B, so 6 belongs to the union. And there's a 7 in C, so 7 belongs to the union. All right. So B union C is this set with 2, 3, 4, 5, 6, and 7. Now I am doing set A intersected with this set, the B union C. Alright, so now this is intersect. This is like the word and. Alright. So again, I'll make a little brace here. Now we're looking at this whole thing. So this is equal to the following set. So what are the elements that are both in A and in B union C? So look at the elements of A. Is 1 in both of them? No. This set doesn't have a 1. Is 2 in both of them? Yes. So the element 2 is in this intersection. Is 3 in both of them? Yes. Is 4 in both of them? Yes. And then is 5 in both of them? No. It's only in the B union C. 6 is only in the B union C. It's not in A. And 7 is only in B union C. It's not in A. So the only elements that are in both A and B union C are the elements 2, 3, and 4. All right, and then they do draw a little Venn diagram here, and I'll do the same. All right, so just to show you how you could draw it yourself. So remember, usually there's a big box representing the universal set, right, representing everything. And then we have these 3 circles that overlap, A, B, and C. So say this is set A, set B overlaps it, and set C should overlap all these. It should overlap both of them. So overlap A and B. And there's set C. And then I'll label where the elements are. So the element 1 is only in set A. So it should just be only in the spot of A that's not in any of the overlaps. The element 2 is in A and C, but not in B. So that'd be in here. The element 2 would be in the part that's in the A and C overlap, but not in the middle. The middle is where all 3 overlap. The element 3 is in A and B and C. So that's in this middle part. The element 3. Sorry, this is tiny, but it's 3. The element 4 is in just A and B, but not in C. So the overlap between A and B, but not the middle. Right? So this part here, there's 4. The element 5 is in just B and C, but not in A. So the overlap of B and C, but not in the middle. There's the element 5. The element 6 is just in B. So just in the area of B that's not in any of the overlaps. And the element 7 is just in C. So the element is just in the part of C that's not in any of the overlaps. All right. Now, we said down here that this A intersect the set B union C has only the elements 2, 3, and 4. So that's these areas here, right, with 2, 3, and 4. All right. And that's now they have their A, B, and C in a different orientation than I do. They have like A on top, then B here, then C there. But the same area with 2, 3, and 4 is colored. All right. And I'll play the animation. Just to show you now, see what they do is, here's again, their Venn diagram for this. So there's set A, with 1, 2, 3, and 4. There's set B with 3, 4, 5, and 6. There's set C with 2, 3, 5, and 7. And then you're trying to find A intersect, B union C. They do B union C first, as we did. Right? 2, 3, 4, 5, 6, and 7. And you see they color that in. What they've just colored in here is B union C in red. And then they intersect that with set A as we did. Right? They color in set A, and intersection is where they intersect, where they overlap. See where the blue and the red, where set A in blue and set B union C in red, where they overlap. And blue and red make purple, so they make that a purple overlap. All right, and then erase everything else, right? Because the only thing that we're asked to identify is the intersection. All right. And the challenge activity is similar to this, where you have to fill in things and erase things and fill in certain areas. You'll see when I get to the challenge activity. All right, so here's another one. All right, so again, same sets, and I'll do this on paper, and I'll leave the animation to you. All right, so it's the same 3 sets, right, A, B, and C there, but this time, just ignore this Venn diagram here, because I'm going to make another one. Same 3 sets, but now I'm asked to find A union, and then in parentheses B intersect C. All right, so same deal. I start with things in parentheses. So we're going to find B intersect C first. That's B intersect C. So what are the elements in both B and C? Well, I guess you could look at this. The ones in both B and C are in the overlap of B and C. That's 3 and 5. 3 and 5. Or just look at B and C. See how they both have 3, they both have 5, and those are the only 2 that they share. So this intersection is the set with elements 3 and 5. Right, and then I'm taking A union this set with 3 and 5. So what's this? So this is the set. Now remember, this is this is the inclusive OR. So all the elements that are in A are in this union. All the elements in B intersect C, this set with 3, 5, are in the union, and any elements in both. So 1, 2, 3, 4, 3 again, but I don't need to write 3 again, and 5. So 1 is in it because it's an A, 2 is in it because it's an A, 3 is in the union because it's in both, 4 is in the union because it's an A, and 5 is in the union because it's in this B intersect C. So 1, 2, 3, 4, 5. All right. And that's it, I'm done. Right? So if I was making the Venn diagram again, I'll just draw basically the same picture over here. So here's set A, set B overlapping set A, and set C overlapping both of them. And but you had 1 here, 2 there, 3 there, 4 there, 5 there, 6 there, and 7 there. So the area in question, right, this set represented on the Venn diagram, A union B intersect C, is the set with 1, 2, 3, 4, and 5. Well, that's this area right here. Right. So it's basically all of set A with just this little part of the overlap of B and C with the number 5 in it is the area in question. And that's exactly what they're showing here. But again, their orientation's a little different than mine. But it's all of set A, and then this little part with number 5 in it that is part of the overlap between B and C. All right. Then you have some to do on your own here. Now, again, I'll just do one of these. All right, because I'll leave it to you to figure out the others. So I'll do this big one with all the sets involved. So these are the same sets from earlier. All right, this activity up here, they're the same sets as those. Right. So how about this one? So first I'll do the parentheses, the expressions in parentheses. So I'm doing intersections. Now what's A intersect D? A intersect D would be all the odd integers, right, that are in both of them. So just 1 and 11. So A intersect D has just 1 and 11. B intersect C in the other set of parentheses. B intersect C would be all the even integers that are in both, so 2, 4, and 8. So A intersect D is the set with 1 and 11. B intersects C is the set with 2, 4, and 8, and then we're putting them together, just the union. So 1, 11, 2, 4, 8. 1, 2, 4, 8, 11, this third set here. Okay. And again, you can play with the other ones, write them out if you want. Okay. All right, now we get into some special notation here as well. So far, we've only done the intersection of a couple sets, the union of a couple sets. You've only seen at most a few sets in any of the expressions we've seen. If you ever see this, this intersection symbol, now hopefully you recall like sigma notation for sums. This is very similar. This is the intersection, from I equals 1 to n of a bunch of sets called AI. So you have A1, that's starting with the lowest value here, A1, and you're doing intersections with all the sets up to AN. Right, so A1 intersected with A2, intersected with A3, all the way up to the intersection with AN. And this would represent all the elements. If you're going to be in this intersection, that means all the elements in this are in all of these sets at the same time. Right, it's one giant intersection. And then the other way around is the union, right? If I take the union of a bunch of sets, say set A1 union, set A2 union, set A3 up to set AN, any element in this set is an element that's in A1 or A2 or A3 or any of these sets, right? Any element that's in any of these sets is in this giant union. Okay. So let's just look at this one example here. So for this question, the universal set is the set of words in the Oxford English Dictionary. For each positive integer j, we'll define set A sub j to be the set of all words with j letters in this dictionary. For example, the word discrete is an element of A8, right? Because the word discrete has 8 letters. Right. So A1 has all the words with 1 letter. A2 has all the words with 2 letters. A3 has all the words with 3 letters. Exactly 3 letters, right? A4 has all the words with exactly 4 letters, and so on. The longest word in the Oxford English Dictionary is this monstrosity here. What is this? Pneumano ultra microscopic silica volcanoneosis, however you say that, which has 45 letters. So the largest, and so this word, right, would belong to A45, right? A sub 45. So match the definition of each set to its description below. So what we're doing here is we're taking these sets, this A1, A2, A3, A4, up to A45, these sets of words, and combining them in some way to make a new set. So about this first one. So this is the intersection of j equals 1 to 45 of all the AJs. So this set here that I'm got my cursor on is A1 intersect A2 intersect A3 intersect A4 intersect 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 all the way up to intersect A45. So the words that the words from the dictionary that belong to this set are the words that have 1 letter and 2 letters and 3 letters and 4 letters and 45 letters. Can you think of any word that has exactly 1 letter and 2 letters and 3 letters and 4? No, you can't. Right? Because a word has exactly 3 letters and that's it. You can't have 3 letters and 2 letters and 5 letters and 45 letters. So there is no word in the English dictionary that belongs to this set. So this set is the empty set. See the first symbol, the empty set. I hope that made sense. Pardon me. This one, see, it's the union, right? Union symbol from j equals 1 to 10 of AJ. So this set is A1 union A2 union all the way up to union A10. So any word from the dictionary that belongs to this set is a word with either one letter or two letters or three letters or 10 letters. So this is going to contain all the words that are from 1 letter long to 10 letters long. So this is a set of all words with 10 or fewer letters in the Oxford English Dictionary. Again, hopefully that makes sense. And then this one is all the words, right? The set of all words in the OED, because it's the union of, this is A1 union A2 union A3 union up to A45. So any word that belongs to this set has either one letter or two letters or three letters or 45 letters. Well, every word has either one or two or three or four or up to 45 letters according to this. So this set here contains every single word in the dictionary. So again, hopefully that notation is clear and is explained pretty well up here. All right, now for the challenge activity. Now I said earlier, this is going to involve highlighting certain regions based on what set has what elements in it. And you saw me do some coloring in on my paper, but so here, select the region for set A. So set A is this region, basically everything inside the blue circle, right? That is set A. I have highlighted region A. That's it. How about C union B? So it's all the elements that are either in C or in B or both, right? So I'm going to keep the overlap of C and B highlighted as well. So there's C union B highlighted. A intersect C. So this is what's in both A and C at the same time. That would just be in the overlap region for the yellow and blue circle. Then it gets a little more complicated where, here, again, do the parentheses first. So A intersect B, that's this set here. And then intersect C. Well, here's C. I have A intersect B, intersect C. Well, the only place where both of these overlap is this middle area. So I'm going to get rid of all the other stuff. And there's A intersect B, intersect C, right? This middle part. So I'd recommend, like they did in the animation earlier, maybe highlight certain regions and then make sure that the regions that are highlighted at the very end contain the elements that would be in those sets. All right, I'm not going to do the last one. And then finally, you have your additional exercises, right? And some of these are in assignment 4 that you're going to be uploading to me. Other ones are not. Okay, so I would still recommend that you do all the problems. Take a look at all of them, because the more practice you get, the better. And you can also view solutions, right? You got just to see how well you're grasping the material. And I say this every video, but please try to work on the problem. Try to do these problems before you look at the solutions. Don't just copy down solutions when you're working on these, because you're not going to learn anything that way. And I would like you to learn this stuff. Alright, and if you have any questions throughout the week, of course, send me a message, let me know. And hopefully this video is a nice, is a good guide for you for section 3.3. And thanks for watching.